Now we have gone through the Newton's first law, second law of motion and third law of motion. Now if we take Newton's second law of motion and how we have relation with Newton's second law and first law, we will talk about this. Okay. Now if we go through the Newton's second law of motion, force which is equals to mass into acceleration. Okay. Force is equal to mass into acceleration, and we know that acceleration is equals to the time rate of change of velocity. The time rate of change of velocity. Now if we take there is no change, means v minus u upon t is equal to 0. It means a is equal to 0, and what we are getting here is force mass into this is going to be g. Okay. Here it means it has two meanings. If we are applying a force on an object, means there will be change in velocity, or there will be change in state, that we can say change in velocity, or we can say change in state. If it is in velocity, its velocity is going to change, and if it is in state of rest, it will start in motion. Okay, so when it will happen, when if F is applied, means force is there. Okay, force is there. Now here force is what? If we are acceleration is 0, means there is a force is 0. Change in velocity is 0, means acceleration is 0, means there is no change in velocity. If the object is in motion, there is no change in velocity. If there is no change in velocity with respect to time, the acceleration is 0. The object is moving. Okay, so if an object is in a state of motion, it will remain in a state of motion unless and until an external force is applied. No, external force is not applied, so it is in continuation in motion. It is in uniform velocity. Now if we take change in state, if we are applying a force, what is going to be? This is not going to be 0. F is not going to be 0. And F is not going to be 0. Ma is not going to be 0. Means again there will be a force, and this will change the state, or it will change its velocity. Okay. Means acceleration is indicating its state, either in a state of motion, there is no change in velocity, acceleration is 0, means force is 0. Okay. If object is at rest, what is happening? Again there is no change in position with respect to time, and when there is no change in position with respect to time, velocity is going to be 0, and if it is velocity is going to be 0, acceleration is 0. Again we are having this force. So Newton's second law of motion gives us the Newton's first law of motion. Newton's first law of motion states that if an object is in a state of rest, it will remain in a state of rest. If an object is in a state of motion, it will remain in a state of motion unless until an external force is applied. If you are applying a force, it is going to change its velocity. Means acceleration is not going to be 0. There will be change in the velocity, and consequently there will be change in the acceleration. Similarly, if we go with, if no force is applied, means acceleration is 0. Acceleration is 0, means either it is in motion, there will be no change in velocity, and if it is in rest, definitely there is no change in position with respect to time, and then no change in velocity with respect to time. Okay, so this way we can interpret Newton's second law of motion for the first law. Means Newton's second law of motion also contains the Newton's first law of motion. Okay, now we can see another example for this, Newton's third law. Now third law, if a force is applied on an object, the force is acting, suppose in this direction, say B to A, on an object, and there is a force which is acting from A to B. Okay, one object is moving, the force is acting like this in according to Newton's third law of motion. Means FBA, that we can say FAB is equal to 0. Okay, now if we go through the object, say it is having some mass m. Okay, there will be change in momentum with respect to time. Okay, so we are assuming that change in momentum, that is dPAB. Now see here what we are getting, force on B because of A and force on A because of B. Both are acting in opposite direction, equal in magnitude, that we can say. Now if we go with this, how we are getting this? This in terms of momentum, it is going to be this. And if we go with the AB, it is D this. Now if we put these two values, dPB upon dt plus dPA upon dt, here we are getting equal to 0. Now if we see here, it is like this, dP. Now in the absence of external force, the momentum is going to be 0. And if it is going to be 0, so definitely the force which we are getting here for this, both are equal in magnitude and they are acting opposite to each other. So this we can take it from the Newton's second law of motion. The time rate of change of momentum is 0. It means the momentum is constant. And if momentum is constant, means there is no forces applied on it. The two forces which are acting in the direction opposite to each other, equal in magnitude. Okay, so from this Newton's second law, we got this first law as well as third law. So, a Newton's second law contains the first law of motion and second law of motion. Okay.